Right, so let's stop talking about generalities and let's talk about some specifics. I'm going to give you two examples, and they're both health examples. So the first one, A&Es, is something Johnny and I spend some time thinking about. And one of the constant calls on our attention is people pitch up at A&E, should they be there? Should they go somewhere else? Should we put that huge great big sign which Bradford BRI has outside saying go away, essentially, but massive overthink, do you have to be here, and so on and so forth. So we'd like to know something about the patients as they arrive. So I've formulated a question which is probably a simpler one to answer, just to test it. So what we're going to do is try and classify patients on available information. See, it's very much like the marketing work. What information have you got? What can you glean from that information that tell you something about that person? So first of all, we're going to have a look at, if someone pitches up at the front door of the BRI, what do we know about them? Can we predict they're going to be admitted or not? I think about 25-30% of patients are admitted, something like that. If you just pitch up at the door, do we know you're going to be admitted or not? Compare that to a doctor guessing. Nothing clinical, just about where they're going from. Now, I'll just give a little bit of background to this. What Azure is actually doing is we're setting up a model which is a sort of one-time process. When we come up with that model, the idea is that you have an input and an output, so you put the data in, an output comes out, and that would normally be embedded in sort of web application. So you see this happen all the time, that when you're buying something it says, do you want to buy this book as well? It's doing that sort of algorithm. So this might be, in this example, the receptionist at the hospital will take some of your details, where you've come from, your age, time of day, things like that, and it will come up with a flag saying high risk of being admitted, low risk of being admitted, and it could come up on the screen. And that could be used to streamline some of the patients into a fast track. If they're a high risk of going to be admitted, let's get them in fairly soon. So it's like an automatic triaging process. So I'm going to talk about the bit in the blue box, I'm not going to talk about the web application. Let's start with some data. Johnny has been setting up some test data which is anonymised. So on this test data we've got nothing about patient ID, no HES IDs, nothing, no SUS IDs. We've also stripped out of it actual time of day and actual day of the week. So down on the right hand side I've got day of the week by 1 to 7 from Monday to Friday, month by 1 to 12, and time band by 6-hour blocks, which has been derived from the original time and date. I've done that in Excel. You can do that in Azure, but it's easier in this case to do it in Excel. So let's disappear out of here. Let's go into Azure. So this is a spreadsheet. It's been saved as a CSV file. So we're now going to get that on the screen. And I'm going to say we're going to do a new experiment. How do we do a new experiment? We press that button there. And what we find is there's a lot of experiments which you can start with, which are part of their learning set. So if I went over on any of these, I could open one of the examples they've got, and these should link up with the training videos. Oops. I'll go back to using my mouse. There we go. But we'll go for a blank experiment. Yeah, that's fine. So we have a canvas that looks like that, and what it says is we're going to start taking modules, and that's how this works. We have modules which you drop onto a template, we connect them up, and it's in effect a wiring diagram. So there's no coding. You can do coding if you want, but be careful. So if we go to save data sets, mine data sets. So yesterday I took that Excel file, I uploaded it, and I've called it Demo A&E, and I drag and drop it onto there. We started! That's it! What have we actually got there? These little bulbs here. Has anyone seen this before? Or is this all new? If we go onto that, you can always see something inside it, so it's going to say visualize. We're going to have a look at the data set. So that's the data set that we put in. It started off as a CSV file, it's brought all the headers in, and it has this useful little histograms at the top. Why is the histograms useful?
Distribution.
Yes. Whenever you do statistics, you want to know, are your variables distributed? Ideally, they're normally distributed, because everything works beautifully if it is. If they're not distributed, if they're just a single value, then there's no point in using it. Go away. So that gives you some sort of, you can look at this and you can look at any of these, and it gives you some useful information, so you can say, should I be using that or not? That was easy, wasn't it? Now, the process, remember those corky things? I'm going to come back later and talk about the data, because I think 90% of the problem of this is not doing what we're going to do now, is getting the right data into that block there. And I think that's where all the clever bits come, but I'll make some reflection on that later. So I've done all the clever bits, which took me about 2 weeks last week, and we're going to start doing some experiments. Now, first of all, what we do is we can select columns, so you just put select. Down here we have all the boxes that we could possibly want, and we join them up. Now if we can join them up, if it lets us do that, we're in with a good chance. But it's come up with a little red block there, so I'm going to do something. It'll run. That will probably disappear. You can see it running, because in the top right hand corner it says, I should say running. What we're going to do here,
David, don't need to define which column you want to select. That's all the others.
That's what I'm just about to do here, because I should still be able to run it, I think, at this stage. What I'm going to do is I'm going to select all the columns except for one. So this acts as a filter. The disposition is, are you sent back to your GP or you sent to an outpatient clinic? So we're not interested in that. Let's just go for that one. So essentially that's acted as a filter. The data started there. All the data is going to go through that, except for the one that we've taken out. We're going to clean it as well, because one of the problems you quite often have in large data sets is clean missing data. Can we join that up? Yes, we can. And then there's some rules for cleaning the data. So we're going to use all the columns. Yep, we're happy to use all the columns. And what it's going to say is, if there's a missing piece of data, I'm going to replace it with the mean. You can actually just remove columns that haven't got data, but I'm just going to replace it with the mean, because there aren't that many missing columns. And now we're going to do the first bit of the actual. You can do a lot of other pre-processing in here, which I'm not going to. You can put modules in here which run R or Python. So if you want to do some very clever things, then you just drop one of those in. Let Johnny know if you want to do that, because he does that, I don't. So we're going to split data. So what this does says, right, I've got two outputs here. I've got output 1 and output 2. I'm going to split one lot into one lot and the other lot into the other lot. And we're going to do it on a 50-50 basis. I'm going to change that to 7. So 70% go down one lot and 30% go down the other. That's a sort of, depends on how much data you've got. And then I'm going to get into the interesting bit. I'm going to say train model.
So in terms of the split, have you got any
split it? Is it totally random? Is it just
Well,
a black box?
That's randomised because it's randomised split, and you can put a seed in there if you want to reproduce it. If you want to test it many times, you do the thing where you have random things, but you have a predictable random. How does that work? I never know. But yes, you can do some things on that. I think what you should be seeing now is you've got some controls over this, but not very many. So if you were normally doing this in code, you'd have an infinite number of choices. All those choices are being removed from you. I think Johnny's going to say something about that a little later on. So we're just going to join that split data bit there. Now we're going to say, well, how are we going to train it? Now, this is a little bit of the dark art. We're going to have a 2 class. Which algorithm you actually use? Classification. What we're doing is a classification 2 class boosted thing that I think I'm going to use. So what that's telling is, this is the algorithm I want you to use. Now, this is the sort of thing, well, why have I picked this and not another one? Well, as I said earlier, it tends to be a suck and see thing, which I'll talk about when I give the other example. So we're going to train it, and then we're going to score the model. Remember I said that what we're going to do is run it, test it, and see if it works. So we're going to take the other data set there, we're going to take that up there. Now, have you noticed that one, let's come up with that little blob. It's going to say you're doing a training, but what do you want to train it on? So we're going to do column selector, and I'm going to train it on admitted. So it's going to have a look at that's the dependent variable, which has gone into there now. Almost there, school model, we want to evaluate the model. We want to know is it any good or not. And I'm going to have an output as well, because I like these outputs. I'm going to convert, I'm going to be able to get the data back out. And that essentially is the model. Right, how confident are you if I press run, something will happen? Hands up if you think this is going to be an absolute disaster and I'm going to spend the next half an hour trying to work out what's gone wrong. Thank you. Let's press. It should run fairly quickly. There's 130,000 lines of code in this. This is an A&E department run for a year. The data's come from. So that's 130,000. So it's running, there's a little thing up there that says it's got into the queue, it's run. Just a little side issue, when you set this up, it asks you where you want the data to be stored. And I wasn't quick enough on the thing. So this data is actually running in America at the moment. You can choose Europe, which is what I should have put, but...
if you get the option UK South, if you don't get the option Europe, if you don't use actual NHS data, it has to be UK South.
I don't think the ML this.
That doesn't have UK South.
Yes, I think it's Azure main has that. But so we only get the choice of Europe or America or somewhere else. But anyway,
David, how secure is the data? Because that's the question. Is it sort of in a site that's generally open, so that you have to watch what you do?
that's above my pay band.
John Wilshaw has some materials on security and cloud for this sort of data. Essentially, if we keep it within the UK, we are secure, and you can see that on the documents. As soon as you start sending it to external servers, things get much more complicated.
So it's run. We've got ticks on all the boxes. What will happen is there's a fault. Is it won't get to a certain point, you get a red dot rather than a tick. If you've got ticks everywhere, that took about 30 seconds to run. So let's have a look at this blob and say visualize. Let's score the model. And what this shows us is that's the data that we've put in. The admitted is the dependent variable, and the scored label is what Azure has come up with its machine learning. So if the two are the same, we've got it right. There's a probability score there. If there's a difference, that one for instance, that patient was admitted and we think they are going to be admitted, we've got it wrong. And the question is it right enough for us to use it, or is it so wrong we wouldn't touch it with the barge pole? And what you find is you go into the evaluate model bit, visualise, and it will come up with this ROC curve, and if you've done any medical diagnosis stuff, you will see this receiver operator characteristics. I think that was ROC. Essentially, if you've got a test, then all the results come up on that straight line. It's no better than just flipping a coin. It's just random. The closer that line is into the top left-hand corner, the better it is. And it actually comes up with a little number here. We essentially got 80% of them right, 81% of the right. These are the true negatives, so these people we thought were going to go home, they did go home. These are the people that are true positives, these are the people that we thought were going to be admitted. They were admitted, and they're the ones that we've got wrong. So that should come up to 18%.
Can you tell it to err on the side of caution? If in doubt, say they're going to be admitted.
Not on this one, we can't.
Right.
Remember, there's no medical evidence. The only thing we've got is time of day, where they've come from. Did they come from a deprived area? The distance they've travelled. Have they come by an ambulance? We can actually look at the algorithm that it's come up with. If we have a look at here, model, visualise, and this will show you how it's come up with those solutions. It will be a node thing here. And what it does is, because it's a decision tree, it looks at each of the factors and looks at where the tipping point is, whether you should be left or right. And you can't see that. So the biggest factor is, did you arrive by ambulance? Well, blow me down, I couldn't guess that. Then we start with age. What's your age? And then if you go further down, I don't know if I'm getting further down. You start to get time bands coming in and other things. So these are all secondary things. So it's working in a very logical way, but it's taking the information it's got and improving the way it does it. You're happy with that? So what you've seen is we started with a CSV file 10 minutes ago. We've done the drag and drop, and we've come up with an 81% prediction of just guessing when you walk into an A&E department if you're going to be admitted or not. And you don't need the 12 years of medical training to do that. Just do it on the demographics. Okay with that? I'm just going to move on. I'm going to give another example and show how this works in a slightly different way. So that's the import, that's the hardware. That was the plan, that if it all failed, I'll just show you that. There's that tree that we've got, and there's the results we've got. There's the ROC curve, and you can see 7% of the true negatives we got right, 12% of the true positives we got right, and it's 11 and 7. And this is probably where you're coming in. Would we err on the false negatives or the false positives? Which way is it balanced? At the moment, it's erring